Analytics breakout session. I'm Dave Robertson, and my job is to chair the panel. In a moment, then you'll be introduced to the three speakers. But for just a little bit of context and where we are with this from an HDR UK point of view before I introduce the speakers. So in HDR UK, we've got, I think, a fairly firm grip on the concept of a trusted research environment. So that's great. And we know how to manage both the governance and the technical issues of standing up various styles of analytics within that sort of closed environment. And that's a big step forward because it gives a strong base for doing serious data analytics on health-related data. But it won't be enough because TREs have been built locally, where local means specific to a region, for example, Scotland, where I'm typically based, or specific to a type of data like genomics or something like that. And we need national and international data for many of the analyses that we want to run, and we need it at scale, a truly national or international scale. We're unlikely to do that through building a vast national trusted research environment. So you need to think about how we bring together data for specific analyses across TREs and how we run the same analyses across different TREs. And to do that, we need to address a whole load of technical issues: how to reliably move compute to data, how to limit scope of data if we need to pool features of data sets in different TREs, and the extent to which analytics algorithms can be made into commodity services, things like that, big, meaty technical questions. We also need to address governance issues. Who governs the ecosystem? How to engage industry? How to build a non-partisan infrastructure that doesn't require a specific organization to sustain it? And these sorts of questions, if they're taken to their fullest extent, are really demanding and quite often open-ended. But HDR UK is looking for practical approaches that can be made real in the next couple of years. So we need to think of what's practical in the short term while being mindful of the broader ambition. And we need to identify the milestones along the way and the use cases that will demonstrate that we're truly making progress. And we also need a map. So there's already a green paper describing our broad ambition, but we need to turn this into a white paper that defines future actions. So our job in the next 45 minutes is to discuss this. Each of our three panelists will present for 10 minutes, and then we have a little time for questions and discussion after that. So all that's left for me to do until we return to the questions is to introduce the panelists in order. And there are three: Roger Noble, Mandy Chessel, and Emily Jefferson. So Roger Noble is an entrepreneur, software developer, and data visualization expert who's focused on creating new and innovative technologies that provide equitable access to data regardless of an individual's background, location, or technical expertise. He's the founder and CEO of Zagami, an image visualization platform, and he's passionate about raising awareness of issues with data quality, bias, fairness, and diversity in AI. Mandy Chessel is an IBM Distinguished Engineer, Master Inventor, and Fellow of the Royal Academy of Engineering. Mandy is a trusted advisor to executives from large organizations, working with them to develop their strategy and architecture relating to the governance, integration, and management of information. She's also the project lead for the Linux Foundation's Egeria open source project for making metadata open and automatically exchanged. Just to show I've done my homework on bios, in 2015, she received a CBE, I believe, for services to engineering in the Queen's New Year's Honours List. And Emily Jefferson is the academic lead and director of the Health Informatics Centre, HIC as we often call it, at the University of Dundee, and chair of Health Data Science. She's a team of more than 50 people providing research and services to over 700 different research projects, bringing expertise in health informatics, data science, data management, governance, machine learning, and AI. She's responsible for an ISO 27001 certified infrastructure and a Scottish Government accredited safe haven. Emily's main research interest is in innovative automated methods for the provision of sensitive linked data, which meets both governance requirements and those of the research community. She's leading several data federation projects across Scotland and the UK in collaboration with HDR UK. So those are the panelists who will now give you 10 minutes talks each. Over now to Roger.
Oh, thanks, Dave. And hello, everyone. Just wanted to say thanks, everyone, for your time and attention today. As Dave mentioned, I'm from Zagami, and we have an image visualization platform. And what it does is allows you to easily find patterns, outliers, and trends in large amounts of images and visual data. And we sort of help you to uncover biases and misclassifications that can make their way into machine learning models, and really to help assist with helping to explain the inner workings of AI, in particular machine learning models. And it can be used by data scientists, researchers developing their own machine learning models, as well as by regulators, clinical safety officers to help validate and interpret AI. But for today, I wanted to talk about federated learning, which is an approach to the distributed training of machine learning models and overcomes many of the limitations and problems that can arise when trying to do that. So next slide, please. Great. So I think we can all agree that there's a strong need for AI within healthcare. It was actually earlier in the year, the Royal College of Radiologists reported that there could be shortages in consultant radiologists between 27 and 37% across the UK by 2024. And COVID-19 has also just really highlighted that there's a need to better utilize the resources that we have through using assistive tools and automation to help really lighten the load, and also to just reduce direct contact with patients. To create AI and specifically machine learning models, there's a need for them to be trained though on lots of data. And when it comes to developing and adopting AI, one of the biggest challenges is just ensuring that it's done in the right way, maintaining data privacy, diversity and transparency. For those that aren't familiar with how you go about creating machine learning models, it's a process called training, whereby the model is shown lots of examples of labeled data. It could be images or sound, video, but over time, it learns how to identify sort of overarching patterns and features within a data set. A real simple example is you can train a model to learn the difference between a cat and a dog just by showing it thousands of examples, and it will eventually learn those qualities of an image that make it more cat-like or more dog-like. And it's sort of through attaining enough examples that really leads us to the challenges that we face. Next slide, please. So developing AI, especially in highly regulated environments like healthcare, presents unique challenges that can be less of an issue in other industries. So like thinking of our simple example, if we fail to predict a cat as a cat in an image, that could have pretty low impact, in the grand scheme of things. However, if we fail to correctly classify a tumor, that could have a huge amount of impact on an individual or many individuals. And part of the reasons and part of the challenges in developing robust models is that there's just huge amounts of data to deal with. And actually up to 90% of the data that's being generated is images in particular, which have problems in that they require a lot of storage to keep, a lot of compute to process them because of the sizes. And also they're just difficult and slow to move around. There's bandwidth constraints that come into play as well. And in many other industries, the cloud is a viable option for solving a lot of these issues. However, there's data privacy issues that are at play in a lot of cases with the cloud, but not only that, there's just bandwidth issues and simple issues around just actually getting the images and the data into the cloud in the first place in order to be able to process it. One of the other issues is just around maintaining control over the data and data governance. And it can also, pulling together these data sets from multiple sources can come to odds with the privacy implications and the making sure that we have the correct governance in place. It's a huge issue. You can't just sort of give people's data away that could be personally identifiable. Machine learning, though, is sort of hungry for data. It needs to have as much data as possible in order to create robust and sort of well-rounded models. And also sometimes there isn't just enough of the right kind of data available at any one single location. TREs, trusted research environments, are a great approach, but then how do you share data between multiple sites when you need to be able to get access to data or insights that aren't always available in one single location? This also then leads to other issues around bias, unfairness, and inconsistencies that can unhook models, cause them to underperform outside of kind of the lab or where you've generated them. Data itself is the highest contributor to the overall performance of models, and I think it's pretty fair to say that a model is only ever as good as the data that it's used to train on it. You know, as they say, garbage in, garbage out. And in fact, it's been found that as much as 96% of all AI projects run into issues with data quality and annotation quality, which can impact the overall costs of running a project. And not only that, once you've trained a model, it's even more difficult to ensure that they're robust and free of bias when running in the real world. These types of issues can have really big implications, especially in healthcare, where it can have a direct impact on people's lives. In fact, one study found as much as 42% of published peer-reviewed machine learning papers contained significant testing errors that compromise the overall quality of the models. Having diverse data that's representative of the population and is free from other biases is critical to the success of any AI algorithm. And this includes demographic data like age, gender, ethnicity, but should also include environmental impacts like how the patient was imaged and the type of make and model of equipment that was used to take the images. All of these can impact into how well the model performs in different scenarios and different environments. Interestingly, actually, it's worth highlighting that actually the UK is one of the few places in the world where there is a rich diversity of data and is a real strength when it comes to machine learning. And it's sort of up to us to kind of make sure that we use it appropriately and make it available. Finally, in many cases, machine learning can be a bit of a black box. You can't fully understand an AI system, then how can you ensure it's safe to use in a clinical environment? The one way a model behaves could be different from patient to patient, hospital to hospital, again, because a lack of real diversity in the data. If a model can't be explained, then how can we mitigate the potential issues that might arise? Next slide, please. So the solution to many of these challenges can be resolved via a technique called federated or collaborative learning. One example of federated learning here is from NVIDIA, produced sort of recently through some of the work they've been doing with researchers both locally and internationally, including King's College and University of Cambridge and several others. And you can use it for different use cases, different modalities, including stroke detection, breast screening, and more recently for COVID-19. And there are a few ways that this can be done, and the diagram sort of explains just one approach. But as you can see on the right here, we have multiple collaborating sites, hospitals and research centers, and there's an initial deep neural network that is securely transferred to each of the sites that are collaborating in the project. And then using their own resources, their own data, they each train a model, and it's sort of done within their own secure environment. They have full control over the process. But the training that then happens could be at any location they're choosing as well. So it could be on-prem, it could be in a private cloud, a public cloud, within a TRE, it can be wherever, but they're sort of training their own models. But then, as you can see, the diagram sort of shows then that once it's completed, the model parameters are then sent back to this, what's called a federated server in this image. And what that does then is combine all those parameters into a single global model. Just sort of to, if you're not familiar with these sort of model parameters or weights from a deep neural net, it's sort of like a series of values or numbers that really underpin the model itself. And what's neat about them, and by their very nature, is that they're not usable in any way to allow for any kind of jigsaw re-identification type process where you could kind of reverse and identify somebody from them. And so that's why they're quite unique in that you can keep the data, on site within your control, but then share these weights in a way that doesn't compromise, any kind of security or any kind of governance around that data. This overall process of creating the global model can happen in multiple times. It can happen with multiple participants. Participants can come and go as they will. But the end result is a model that benefits from being trained on the entire data set from all of the sites. And so it is able to get that diversity that is sort of lacking potentially if you're just looking at sort of these siloed data sets. This is just one example of how it could be done. It doesn't need to have a centralized federation server. There's other approaches, a peer-to-peer approach where each site could share their models and reassemble them themselves. You could also account for different biases between locations and kind of average them in different ways. But the approach overall has lots of advantages. One is highlighted, it allows the models to be trained on much larger and diverse data sets. And helping to really ensure that the resulting models are generalizable and reducing the effects of localized bias. As mentioned, there's no patient data that's being transferred, and so it addresses not only privacy concerns, but also because the weights are a lot smaller than sending across lots of images, it saves on bandwidth and storage and other constraints. And it's all completely secure. In this sort of scenario, all the peers or all the training sites need to authenticate to a central server. So there's no risk that sort of outsiders could come or get access to the data. So overall, it's a collaborative approach and is quite a neat way to solve many of the issues that arise from gaining access to large, diverse data for machine learning. Next slide, please. So that's all I had. I just want to thank you again for your time and hope that was of interest. More than happy to answer any questions at the end of this session. And also if there are any other challenges or anything that sort of resonated, yeah, don't hesitate to reach out on the either at zagami.com or via email here. Yeah, thank you and thanks for your time.
Okay. Okay, so we go to my charts. Okay, so hello everybody. As Dave said at the introduction, I spend quite a lot of time with different companies in different industries, talking through the process of how they share data between their different parts of their organization or with business partners. And what's surprising is, despite the differences in the way and the types of data and the types of processing that are being used by these different organizations, there really is a common thread that runs through so many of these organizations. And I thought I would share that with you today in helping you with your work on federated analytics. So if we go to the next chart, most people understand that data quality is important, and Roger talked about that, but they misunderstand the difference between what's quality data to them may or may not be quality data to another organization, because there's a context that the data that they capture in their project, no matter how careful they are, there's always a set of assumptions that everyone in the project team knows about. And we call that the context, and it might affect, well, this is the precision we're using, this is the type of measurement tools we're using, this is the type of processing we're doing on the data. And all the time that data is being used within that context, that tribal knowledge about the data itself and how far you can push it and where it's applicable to different environments is known, because that's what the project team know. And they are almost certainly aware that they need to create metadata around it to help others in the project, new people coming on, to find that data. And that's, that's part of the process. But one of the things that many organizations find when they start to share beyond that original group and that original set of assumptions is how much and how difficult it is to really capture that context in a way that is useful to others. And what you really need is a common language to talk about precision and meaning and values and processing styles. So that's really, and that's something that actually needs investment in terms of maybe it's an ontology of the different types of data that are in each of the the research environments, or but also there needs to be standardization around the capture of all of the different dimensions of the data and its quality. And that data is something that needs to be invested in and managed. So we talk about metadata management. Metadata is data, and it needs the care, the same type of care as you do on the actual values of the data as well. So if we go to the next chart. Now, the other thing that happens when you start to share is that different organizations benefit from the investment that a particular organization has made in their metadata. So if we've got an organization that's very conscientious, they are following all the best practice standards for describing their data, or their data is fairly straightforward, so it's not too much effort, then it's not them that benefits. It's like people who are next to a motorway never benefit from that motorway. And that's part of the problem with metadata management, is that the cost is often to a different group of people than the people who really benefit because they're downstream. So if you click again, I think, yep, and click again. So often you get resentment building up between the teams because they feel that, they're not getting value. So one of the ways when you're designing a governance program, particularly in a shared environment, is to make sure that the services offered to the team that do the investment in metadata brings value to them. So because they're creating metadata, they are becoming more effective themselves in their own projects, and they see that value. And then because that metadata is in a common language and it's useful to other teams, that value is enhanced. And as it's consumed, that value comes back to the original teams. And typically we do design thinking workshops. So this is where we look at the personas of people in the different organizations and their perspective on the sharing environment, and look at their goals and their motivations. And generally you come up with processes that even people who are completely anti data governance and all this type of control, because they're free thinkers and whatever, they actually see that some of the more grungy parts of their work are automatable because they're part of this ecosystem. So it's part of the design of the ecosystem to think about the motivations of the individuals, because naturally we are dreadful at doing admin. And so we have to build that into the processes. So that's a sort of the major lessons. If we go to the next chart, what I wanted to go through was some examples of the different types of mechanisms you can use once you've got this metadata sharing in place. So one of the typical ways that business works when it comes to data sharing is they do what's called a managed copy. And so the data is copied, maybe it's going between two organizations. And that data has terms and conditions, a license you can think of associated with it, that provides that definition for what you can do with it. Is it for commercial use? Is it, how it has to be secured, when it must be deleted, how you prove all these things are true. And so you basically have to demonstrate that you are meeting the terms and conditions associated with that data. Because basically once it's copied, you've lost control of it. And so you have to have that trusted relationship with the organization that you're sharing data with. And that might not be appropriate for all types of organization. So stepping back a little bit, it's back from actually just handing the data out. What you may offer is a managed sandbox. So this is where people can connect their data science tools to a copy of the data, but that data is within the original research environment. And it's catalogued and time boxed. So that means it gets deleted at a certain point. So the cleanup of that data is handled, and you have already, and you've also been able to redact anything that you don't want the researcher to see. So they see that data, they're able to manipulate it in the way that they need to do their analysis. And then you need to have a think about, what do they get to take away? You know, if they come out with a number, is that okay? Are they able to come out with a slice of data? So that needs to be part of the sharing agreement. And it still needs to be with trusted individuals, because of course anybody can do screen captures and various sharing if you have people who are unscrupulous who are part of it. So again, this still needs trusted individuals that are part of it. The next thing you can do is say, well, I'm not going to let people touch my data. I'm going to offer a series of services that allow well-defined queries to be issued on the data that are secured, and obviously these are validated users that are accessing it. And that way I know who's making what queries, what people know, which is often a thing that's really important to auditors. And you can limit how many records come back and exactly what people are doing with it. So that's another way of doing it. It obviously creates a very restricted view. It's for research work, this may be too restricted, but it is an option for certain types of data. And finally, very similar to Roger's example, is where you offer a place where people can give you code and you run it in your environment. And obviously that code runs in a completely monitored and protected environment. And then you return the results. So you are able to monitor everything that code does. And that gives the researchers real flexibility on what's being run but the organization obviously can have a very close check on how that data is being used. Now, of course, it does take a trust on both sides, because that code needs to be open source effectively so that it can be validated. But you may be, the researcher might be unhappy to give their algorithm away. So this is where the negotiation and the trust needs to come through as you start to think about, are you sharing data or are you sharing processing? So that's really the questions I wanted to, or the thoughts I wanted to leave you with from industry. But I'm now ready to hand over to the next person.
My unmute button moved from one screen to another. Hello, everybody. Hopefully you can see and hear me okay. So thanks very much to the previous speakers. Really interesting talks. I'm going to talk about a slightly different, take a slightly different angle here, and that's to look at some specific implementation projects where we're trying to do federation within HDR UK. I'm going to split the talk into two different sections. Firstly, we're going to chat about what we're doing in Scotland around the Scottish Federated network of safe havens, where we're trialling different solutions to solve the challenges that we have there of working together as a federated network of safe havens. And I'm going to be looking at the three different projects that we have got ongoing, which leverage each other and build upon each other. So we have an HDR UK sprint project around graph-based ontologies. We have a project called Shima, and then we have an HDR UK Federated Scottish Safe Havens project, which I'll also go into. And then we'll finish with a new exciting development, or at least I view it as new and exciting, and that's the CoConnect project, which stands for the COVID Curated Open Analysis and Research Platform. And this is a UK-wide COVID federated project. So I think that's quite a good timely example of what you can do in terms of data federation. So we'll go through that. So So who am I, and why am I kind of talking around this? So this is a topic very close to my heart. I run a regional safe haven called the Health Informatics Centre, and we're both a service and an academic group, and we actually provide lots and lots of different data sets within a trusted research environment, otherwise known as a safe haven, to support various different forms of research. And we have kind of software developers and data analysts too. So we provide a load of different services. So I really want to see a world where we're not just kind of working in isolation as one group, and we're only able to provide the researchers who come to us with the data that we have, but that we're also able to kind of open up a wider world of providing data from lots and lots of different sources in a timely way, which also protects patient confidentiality and trust. So this is HIC, but then I'll explain how HIC then fits in with the wider Scottish landscape. But all of the different safe havens that we have within Scotland all kind of work in a similar sort of way, and this is something that for many of you watching this talk, I hopefully will understand quite well, and that's around data linkage. So the idea is that you can build a cohort of patients from a range of different data sets. In Scotland, we're using something called the Community Health Index, which links together different individuals within different data sets. So rather than providing research community with all of this data in order to answer their particular question, instead we provide a subset of data within a TRE. And a TRE is basically an environment where I've sort of summarized it here, which can take in feeds from routinely collected data, research generated data, disease registries, mobile phones, etc., etc. And we can link that data and anonymize it, and then we can put it in a safe haven environment or a trusted research environment where the data can't leave, but can be analysed in place. Now, within Scotland, we have essentially 5 of these. So we have a national safe haven, and the national safe haven has the breadth of data, which is captured at a national level, originally for sort of government reporting. And then we've got regional safe havens, which have the depth of data, so deeply phenotypic data held within different clinical systems. So there's each of them have 3 main functions, basically kind of holding and managing the data as a data repository, this TRE function as an analytic platform where researchers can come and analyze the data, and also providing research support as well across the different environments. So what we're wanting to do is kind of really work across these different safe havens to mean that we can federate in a way that maintains the patient confidentiality, but also provides timely data. But there's many different things when you're looking at federation, and there's different ways of doing it. So we've already heard from some of the other speakers today around how you can federate based on a model and the NVIDIA platform, but we can also federate based on kind of query, essentially sending an algorithm to the data and returning aggregate level numbers from that particular data set. Or you can federate in a way where you're extracting subsets of data from the various different sources and putting that into a single TRE. And we've actually been looking at all of those different methods of federation. So there's many challenges though with this, in that when you have data collected in different ways, you need to in some way map and have a homogeneity across the different data sets. So you're looking at standard models or standard ontologies between these different models, or concepts, and at some level then that mapping needs to be done. You also need to consider the data security and governance, and whether you're sharing row level information or aggregate level information. And these things all kind of impact as what type of federation you're doing. So here we have the Federated network, and I have a vision that many other people have within Scotland, and that's that any researcher can go to any one of the safe havens and say, right, I would like to see this particular data set, and rather than just saying, right, here you go, you can have the data that's in my safe haven, instead we can very easily facilitate getting data from across all of the different safe havens within Scotland in a timely way. So we do many projects that cross different safe havens, but at the moment it still takes quite a long time to do that, and it's quite a manual process of working and coordinating between these different safe havens. So there's 3 different initiatives that we're doing: the Shima Project, Graph Ontology Project, and HDR UK Federation Project, and they're kind of building and leveraging each other. So I'll describe what we've been doing in each one. So the building the knowledge graph for the UK healthcare data science, the graph ontology sprint project, what we've done is essentially mimic a safe haven environment within our own safe haven environment. So we've had data feeds from all of the different safe havens on real patient data, lab real world patient data. And then we've built a sort of a demonstration environment of this within our own safe haven, mimicking the fact that there's 4 different virtual environments that hold this data. And then we've been testing various different technologies within there. So I2B2 as a query engine and trying to talk across these different things. And then we've done the mapping of the lab data into graph ontologies, and we've learned quite a lot from doing this in terms of the ontologies and things that we want to use, and also understanding the lab data, because having a national lab data set would be really, really good for us. So we've built on that, and that's fed into something called the Shima Project. And here we've been looking at lots of different tools that can help us on our way. So we're not trying to kind of reinvent the wheel and start from a hello world script in terms of how you do all of these things. But we've done some investigation, basically looking at all of the different requirements that we have from across the Safe Haven network, discussing with all of the safe havens how they're technically structured underneath. And then we've identified sort of various different functionalities that we would like. So we'd like to be able to discover the data that's in each different safe haven. We'd like to be able to run queries across those different data sets to understand the cohorts of data that are available. We'd like to be able to run meta-analysis, where you send an algorithm to the data and get aggregate level results back that you can then bring together. And we'd also like to be able to extract the data from across several different safe havens into a single TRE. So now that we've got a much clearer idea of kind of what we need as a network and the different sort of options that are available to us, we've been installing and investigating and kind of interviewing various different vendors, both open source solutions and commercial solutions as well. So this is kind of hot off the press. We're still in the process of making sure that our understandings around this are correct. So this isn't yet to be published, but just to give you a kind of a general feel, we have checked these results with several individuals just listed at the bottom of the screen there. But these are the different options that we've been investigating in terms of setting up this kind of this different environment and the various different properties that they might need to have in order to facilitate this work. So what we're still in the process of testing all of these out to decide which way forward we want to go. So the key thing now is that now we've done sort of the investigation phase, we're wanting to move on to an implementation phase, and we have some funding from HDR UK for this project. We're very much wanting to make sure that anything we build is completely integrated with the HDR UK Innovation Gateway. That will be absolutely key. And we're leveraging a range of different funding streams in order to make this happen. So we're hoping that this exemplar project can really help us roll this out and make what we're building in Scotland then applicable for other groups to adopt as an exemplar. So then I'll just finish with what we're doing around the CoConnect project, which is a UK-wide project focusing on COVID. And this is very much taking the same ideas of the Scottish Federated Safe Haven, but applying it at speed to COVID data for antibody tests. So the idea is that the vision is to transform the UK's COVID-19 response by making COVID-19 related data sets findable, accessible, interoperable and reusable, obviously fair, and providing expert data engineering enabled by HDR UK to support and catalyse their responsible use in research and innovation. So that's the aim, and it's going to be it's going to keep us pretty busy actually for the next 18 months. It's a really groundbreaking project in terms of the infrastructure that we're putting in. So we have 44 different data sources that we're trying to onboard into this federated platform, and the idea is that we receive the data from the testing. We link this data to other relevant data such as PCR data, multi-morbidity data, BAME, age, etc. And each different data partner is supported to put a pseudonymized version of their data linked into a database using the standard OMOP format. And we're then using a software written by BC Platforms, which is going to help us do this federated query component. And this BC Platform software will enable the query engine to talk to these different databases. So the data doesn't leave, but you can query it, and you'll be able to query it by the HDR UK gateway, which will integrate the BC Platform software into. So researchers will be able to discover what data is out there in terms of COVID serology data, and we'll be able to run meta-analysis across the different data sets. So because it's in a standardized format, you'll be able to essentially send the algorithm to the data, run the query across it, and get an aggregate level result back. And the other feature is that if you need to see far more detailed row level information, then you'll be able to in an automated way, once you have additional data governance approvals, be able to extract relevant data from the different data sources and put that into a single TRE in order to do your analysis. And that process, rather than taking many months to do, because it will all be automated once you have your data governance approvals, that should be a very streamlined, timely process. So the project's only just launched. We've been going for about a month now, and I really think it will have great impact on public health and government policy. These are all of the different data sources. We have a large number of serology cohorts from different healthcare workers initiatives. Then we've got other data from schools, from care homes, and a range of other places. Then we've got routinely collected data from across all of the main groups who are collecting it from England, Scotland, Wales, Northern Ireland. And then we've also got augmented cohorts as well, which we're supplementing with the serology data. So the objectives then are basically to create a single platform, which is federated to allow us to do all of this, really support access to COVID data from the multidimensional health data sets, and really put in an infrastructure that can be used not just for COVID, but also for other diseases as we go forward. And that's all of the gang within HIC who are currently working on this. Thank you very much.
Great. Thanks. So we've run a little bit over time in the talk, so we'll have to rapidly go through the Q&A. So I'll just wait a moment until we all come up on screen, which is terrific. And so, I'll shout out the questions, and this is going to be rapid fire, folks. I'm afraid we probably won't get through all the questions. We have to stop at 4. We've got about 6 minutes. So first question is really rapid fire for people. So actually, one sentence for whoever wants to answer for each one. If you all three want to, what are the people and process challenges for scaling to use federated approaches to machine learning, data discovery, and analytics?
Automation is key, as much as you can.
The people are nodding. Basically, it's automation is the answer to that. I wonder if Sushil wants to say anything of that. Is that fine? That's okay. Next question is more specific for Roger Noble, actually. So you Roger. This person is curious about what people think about the NVIDIA approach that you mentioned. So you don't need to share your data with anyone, but you do need to accept an NVIDIA box and its software and all of that. Will that be any easier to gain acceptance is the question.
Yeah, I think the quick answer is that if you're doing any machine learning, you're probably using NVIDIA Kit anyway. You don't have to accept their hardware or anything. In this scenario, it's sort of a container, so it's a Kubernetes-based deployment. Again, then automation and ML ops is key for all of this. But I mean, it's just one approach. There are multiple ways that you could do this. You could roll your own if you wanted to. And I guess it's then a question of what's the ROI on that? You know, is it easier just to pick up something that NVIDIA built to make it easier, or look at some other alternative? Okay.
So next one is, I think I'll do a quick question for Mandy. It's a clarification. What's the difference between managed sandboxes and trusted research environments?
So the managed sandbox, when I say that, it's generally for a single data scientist doing a particular experiment, and they need their own copy of the data because they're going to change its content, change its structure in order to be able to do their specific piece of analysis. So that's really what I mean by a managed sandbox. And it can obviously be shared by a team, so maybe it's the same thing.
Okay, so now one a generic one for everybody to have a go at. What are the best existing examples of benefits achieved from federated analytics from healthcare or other sectors? A sentence if you've got one. What's an example of something that's been really successful at doing that?
I've seen it work with teams where people not only are sharing the data and things, but they actually share the results so that people fire off of the value of the results. So even knowing that this didn't work is valuable to stop a team wasting time doing something that's already been done.
Okay.
So not just sharing data, but sharing results.
Right. So next one, another one from Mandy, I think. In your experience, what are the best / successful approaches you've seen that address the metadata, particularly data model standards challenges within and between organizations? It's another one of what's best.
So this is actually why I'm working full-time on an open source project to create that open standards for types, interchange formats, protocols for the exchange, and also the event management piece that's needed to allow automation around the data management and the metadata management. So there's a lot to this, but the most important thing that this needs to be freely available, shared by different industry partners and research teams, so that it becomes, in the way that we do security, it's there, it's always there. We need metadata management to be that embedded, reliable, open, complete solution that allows data to be, the data sharing to just be a standard part of the way that we work.
Great. Now, one I think possibly for Roger. So this one is generalizability of an algorithm is important, but by definition, if important, it means there are significant differences in data from certain patient groups. How do you ascertain whether federated learning in accounting for these differences may have led to a reduction in the precision of the algorithm for some patients?
Yeah, this is a super important sort of big question. And it's something that we're actively working on at Zagami, and with our platform, we sort of help to highlight these types of differences. But you're absolutely right that there are certain patient groups where algorithm A could perform significantly better than algorithm B. And the challenge then is, well, you know, how do you evaluate that? And also, how could you get to a place where you could almost select the right model to use based on the demographics and the background of an individual, so you could sort of have tailored machine learning or sort of tailored algorithms. Yes, super important.
And I'll try and squeeze in the last question if I can. We're just up to time. I'll give this one to Emily, I think. How do we overcome the challenge of linking data between different data sets when some are held outside the NHS? Dun, dun, dun.
There has to be some way of doing the mapping somewhere, and I think that there are various different initiatives for making a kind of a UK-wide spine, so that you're not just using the NHS number, but you're actually using a person identifier across all of the different government data sets.
Great. So I think that's taken us.
And Shahil would like to
sorry.
in
I
there as
missed
well,
that.
I think.
Shahil, do you want to say something?
No, I didn't want to add anything. I agree with Emily's approach, and I think one of the things, challenge-wise, is getting down policy in place to be able to facilitate that. So it's not, us technologists saying this is what we'd like to do. We need to bring in the policymakers also on board and bring those two worlds together.
Super duper. And I think that's with Sushil appearing on screen. I think that's us up to time now, if I am correct. So all that's left for me to do is to thank all the panelists. Thanks for listening in and participating. And I believe we now move on to the next part of the program.